this video, we're gonna do an example of solving linear equations by using Gauss-Jordan elimination, and we're going to apply into 3 equations. So our goal is to make the left side of this matrix looks like the identity matrix 1 0 0 1 0 0 1. The first thing I'm going to do is simply turn this into matrix. So let's see. Our first row, we will use the coefficient 2, negative 1, 1, and 2. The second row, 3, 1, negative 2, and 9. And the last row, negative 1, 2, 5, and negative 5. So first, I'm gonna take 1/2 times row 1 to get 1 in the first row and make our rule. So our new row 1 is 1, negative 1/2, 1/2, and 1, and copy the row 2 and row 3. To achieve our goal, the first thing to do is we need to zero the 3 in row 2. So we multiply negative 3 in row 1, add that to row 2, and that's going to give me my new row 2, and the answer is 0, 5 halves, negative 7 halves, and 6. Next, in row 3, we need to zero the negative 1. So, we multiply 1 in row 1 and add to the row 2. It means 1 plus negative 1, negative 1 half plus 2, 1 half plus 5, 1 plus negative 5, and the answer is 0, 3 halves, 11 halves, negative 4, and next, copy the row 1 and row 2. Our next target is we need to 1 the 5 halves in row 2. In order to get 1, we multiply the reciprocal of 5 halves. That's 2 over 5 to row 2. And the answer is 0, 1, negative 7 over 5, and 12 over 5. And copy again the row 1 and row 3. The next step is to zero the negative 1/2 in row 1. So we multiply 1/2 to row 2 and add to row 1. The answer is 1, 0, negative 1 over 5, and 11 over 5. That's the new row 1, and copy the row 2 and 3. So again, the next step is to zero the 3 halves in row 3 by simply multiplying negative 3 halves in row 2 and add to row 3. The answer is 0, 0, 38 over 5, and negative 38 over 5. Copy the row 1 and 2. The next step is we need to multiply the reciprocal of 38 over 5. That's 5 over 38. Multiply to row 3 to get 1, and the answer is 0, 0, 1, negative 1, and copy again the row 1 and 2. Next, in row 2, we need to zero the negative 7 over 5, multiplying 7 over 5 to row 3. Add to row 2, and the answer is 0, 1, 0, 1. And last step, we need to get the 0 to negative 1 over 5 by simply multiplying 1 over 5 and adding to 1. And the answer is 1, 0, 0, 2. We are done in our matrix, but we need to check it. Therefore, the x is equal to 2, y is equal to 1, and z is equal to negative 1. We substitute x, y, z each row. So, substituting the value of x, y, z in row 1. Therefore, 2 multiply substitute of x is 2 minus substitute of y is 1 plus substitute of z is negative 1. Then the answer is same or balance. Again, substituting the value of x, y, z in row 2. Therefore, 3 multiply substitute of x is 2 plus substitute of y is 1 minus 2 multiply substitute of z is negative 1, and the answer is same or balance. And last, row 3, substituting the value of x, y, z. So, negative substitute of x is 2 plus 2 multiply substitute of y is 1 plus 5 multiply substitute of z is negative 1. So, the answer is same or balance. So, all row is balanced. Therefore, our matrix is correct.
This time, we will do a 4x4 Gauss-Jordan elimination. Since we will be doing a 4x4 matrix, we need 4 starter equations. X plus 2y minus 3z plus 4w equals 12. 2x plus 2y minus 2z plus 3w equals 10. Y plus z is equals to negative 1. X minus y plus z minus 2w equals negative 4. And our goal for this matrix is to make the slant equal to 1 and all the digits below it be 0. Let's start. First is to get all the constants in the equation. For example, is the constants in the first equation will be on the first row and so on. Next is to make the 2 from the row 2 0. To do so, multiply the first row by negative 2 and add the product of row 1 to row 2. And the sum of the two rows will be the new row 2. We now have a new matrix with a new row 2. Now we will have to make the 1 in row 4 0. To do so, multiply the first row by negative 1 and add the product of row 1 to row 4, and the sum of the two rows will be the new row 4. We now have a new matrix with a new row 4. Next thing is to make the negative 3 from the row 4 0. To do so, multiply the third row with 3 and add the product of row 3 to row 4, and the sum of the two rows will be the new row 4. We again have a new matrix with a new row 4. Now we will make the 1 in the row 3 0. To do so, multiply the third row by 2 and add the product of row 3 to row 2, and the sum of the two rows will be the new row 3. We have a new matrix with a new row 3. Next thing is to make the negative 6 from the row 4 1. To do so, multiply the third row by negative 1 and add the product of row 3 to row 4, and the sum of the two rows will be the new row 4. Now we need to change the row 4 for it to be 0, 0, 0, 1. To do that, multiply the fourth row by negative 6 and add the product of row 3 to row 4, and the sum of the two rows will be the new row 4. Multiply the row 4 by 5 to cancel out the negative 5 from row 3. The product of the multiplication will be added to row 3 and it will be the new row 3. To make the 6 from the third row 1, we just have to divide it by 6 so we can have 0, 0, 1, 0, and it will be the new row 3. We now have a new matrix. Next, make the negative 5 from row 2 0. To do so, multiply the fourth row by 5 and add the product of row 4 to row 2, and the sum of the two rows will be the new row 2. Again, to make the 4 from the row 1 0, multiply the fourth row by negative 4 and add the product of row 4 to row 1, and the sum of the two rows will be the new row 1. Now we're gonna cancel out the negative 3 from the first row and make it 0. Multiply the third row by 3 and add the product of row 3 to row 1, and the sum of the two rows will be the new row 1. Again, to make the 4 from the row 2 0, multiply the third row by -4 and add the product of row 3 to row 2. And the sum of the two rows will be the new row 2. Next thing, divide the row 2 by -2 to make the -2 1. And the last thing we should do is to make the 2 from the row 1, 1. Multiply the row 2 by -1 and add the product of row 2 to row 1. And the sum of the two rows will be the new row 1. To check if the matrix is correct, substitute the last column to the variables in the linear equation. 1 plus 2 times 0 minus 3 times -1 plus 4 times 2 equals 12. 1 plus 0 plus 3 plus 8 equals 12. 2 times 1 plus 2 times 0 minus 2 times -1 plus 3 times 2 equals 10. 2 plus 0 plus 2 plus 6 equals 10. 0 plus -1 equals -1. 1 minus 0 plus -1 minus 2 times 2 equals -4. 1 plus -1 minus 4 equals -4.